Basic mechanical engineering to mark questions and their answers. Question: what is the difference between heat and work in thermodynamics? A. Heat and work are both modes of energy transfer between a system and its surroundings. However, heat is the transfer of energy due to a temperature difference, while work is the transfer of energy due to a force acting through a distance. Heat is denoted by Q, while work is denoted by W. Heat added to the system is taken as positive and rejected from the system is taken as negative, whereas work added to the system is considered as negative and work done by the system is considered as positive. Question: what is the first law of thermodynamics and what does it imply? The first law of thermodynamics states that the change in internal energy of a system is equal to the heat added to the system minus the work done by the system. It implies that energy can neither be created nor destroyed, but only converted from one form to another. The first law can be expressed as delta U is equal to QW. Question: what is entropy and how is it related to the second law of thermodynamics? A. Entropy is a measure of the disorder or randomness of a system. It is related to the second law of thermodynamics, which states that the entropy of an isolated system can never decrease, but only increase or remain constant. The second law implies that spontaneous processes tend to increase the entropy of the universe. Entropy change for a reversible adiabatic process is zero. Question: what are adiabatic, isochoric, isobaric, and isothermal processes? Give an example of each. A. Adiabatic process, a process in which no heat transfer takes place between the system and its surroundings. Example: the expansion or compression of an ideal gas in an insulated container. Isochoric process, a process in which no volume change takes place in the system. Example: the heating or cooling of a gas in a rigid container. Isobaric process, a process in which no pressure change takes place in the system. Example: the expansion or compression of a gas in a piston cylinder device at constant atmospheric pressure. Isothermal process, a process in which no temperature change takes place in the system. Example: the expansion or compression of an ideal gas in a piston cylinder device that is in thermal contact with a constant temperature reservoir. Question: what is the difference between an isolated system and a closed system? An isolated system is one that does not exchange any matter or energy with its surroundings, while a closed system is one that does not exchange any matter with its surroundings, but may exchange energy. An example of an isolated system is the entire universe, while an example of a closed system is a gas in a piston cylinder device that is insulated from the surroundings. Question: what is the difference between reversible and irreversible processes? A. A reversible process is one that can be reversed by an infinitesimal change in the external conditions, such that the system and its surroundings return to their original states without any net change in entropy. An irreversible process is one that cannot be reversed without leaving some permanent change in the system or its surroundings, such that the entropy of the universe increases. An example of a reversible process is an ideal gas expanding or compressing isothermally and quasi-statically, while an example of an irreversible process is a gas expanding into a vacuum. Question: what are state functions and path functions? Give an example of each. A. State functions are properties of a system that depend only on the current state of the system, not on how it reached that state. Path functions are properties of a system that depend on the path followed by the system during a process. An example of a state function is internal energy, while an example of a path function is heat or work. Question: what are the applications of the first law of thermodynamics? The first law of thermodynamics can be applied to various processes involving energy transfer and conversion, such as combustion, power generation, refrigeration, heat pumps, etc. The first law can also be used to determine the heat and work involved in any process, as well as the change in internal energy and enthalpy of a system. Pure substance. Question: what is a pure substance, and give an example of a pure substance. A. A pure substance is a substance that has a fixed chemical composition throughout. It does not have to be a single chemical element, just as long as it is homogeneous throughout. An example of a pure substance is water, which has the same molecular formula H2O in all phases. Question: what are the common properties of a pure substance and how are they interrelated? A. The common properties of a pure substance include pressure, temperature, specific volume, density, specific internal energy, specific enthalpy, and specific entropy. These properties are interrelated to each other by thermodynamic tables or equations of state, which can be used to determine the state of a pure substance at different conditions. Superscript 2. Question: what are phase diagrams and what do they show? A. Phase diagrams are graphical representations of the phases of a pure substance at various combinations of pressure and temperature. They show the regions of solid, liquid, and vapor phases, as well as the phase boundaries and a critical point. They also show the saturation lines, which indicate the states where two phases coexist in equilibrium. Question: what is the difference between saturated and superheated vapor? A. Saturated vapor is vapor that is in equilibrium with its liquid phase at a given pressure and temperature. It has the maximum specific volume and entropy for that pressure. Superheated vapor is vapor that is heated above its saturation temperature at a constant pressure. It has higher specific volume and entropy than saturated vapor. Question: define dryness fraction and discuss about its significance. Dryness fraction is a term used to describe the quality of steam, which is a mixture of liquid water and vapor. It is defined as the ratio of the mass of vapor to the total mass of the mixture. It can also be expressed as the ratio of the specific volume of the mixture to the specific volume of saturated vapor. The formula for dryness fraction is X is equal to m underscore v, m underscore l plus m underscore v is equal to v underscore g, where X is the dryness fraction, m underscore v is the mass of vapor, m underscore l is the mass of liquid, v is the specific volume of the mixture, and v underscore g is the specific volume of saturated vapor. Dryness fraction can range from 0 to 1, where 0 means saturated liquid and 1 means saturated vapor. Dryness fraction is important for applications that use steam as a working fluid, such as turbines, boilers, and heat exchangers. It affects the efficiency, performance, and safety of these devices. Therefore, it is necessary to measure and control the dryness fraction of steam in various processes.